This show is fiction. The astronomical observations and research hypotheses it contains simply represent the astronomers' questions regarding the complexity of the universe. At the time, I was working in a large observatory, one of the most powerful of its generation, built on the Atacama Plateau in Chile. For a few years, many of us around the world had been monitoring a strange phenomenon. Almost every day, our screens registered powerful rays of unknown origin. We called them gamma-ray bursts. We were intrigued by the discovery of this phenomenon. According to our observations, these extremely powerful rays came from the depths of the universe. One December night, my colleagues and I had a strange experience that deeply affected us. Until this day, none of us has talked about it. Our observatory was part of a network monitoring gamma-ray bursts. Each member of this network was ready to react to satellite alerts at any time. After an alert was transmitted, our job was to accurately locate the luminous phenomena that usually follow each gamma-ray burst, the afterglow. That night, my team was on duty. With me was Frank, an outstanding technician who perfectly mastered the brand new digital observation simulator we had just received. There was also Leia, who'd come to spend a few weeks in Chile as part of her thesis on supermassive black holes. She had joined us for her last evening at the observatory. As I was reviewing the notes left by the previous team, Frank and Leia were making the last adjustments on their equipment.
Frank, look at these lines of code. I'll put them on display for you.
Oh yes, that's a statistics application. I started it a while ago. It's almost done.
Do you know whether the last team succeeded to restart the immersive vision simulator?
No, the technicians have been working on it for a week. I don't know if they've found the bug.
It'd be great if you could see it working, Leia. You don't want to miss your last night on the Atacama.
So you're leaving us tomorrow morning, sweetie?
Yes, it's been great, but I'm happy to get back on daytime living, and I can't wait to start writing.
Paul, did you see that? An alert from Beppo Sachs. It's just caught a gamma-ray burst.
Great. Frank, you can start the process.
Okay.
So what do you do in cases like this?
Let me explain. Up there is the alert zone. Just follow the cursor. See, it's stopping on the sector located by the Beppo Sachs satellite. We'll take a series of pictures from that part of the sky to see if we can detect an afterglow. Frank, are you getting anything?
Nothing yet. The automatic detector is aimed at 2240 minus 30 degrees. It's being processed.
Very good. Check the data as soon as you get it.
Okay.
Let's keep our fingers crossed now and hope we get an afterglow.
And how long will it be before it happens?
It depends. Usually the afterglow appears within seconds after the burst. Sometimes, let's say, an hour after at the most, but that's not very common. Some other times you don't detect anything. But if the phenomenon happens, it lasts several hours. It can even carry on for weeks.
10 days ago, the other team had a great one. Maybe it's our turn now. In any case, we'll find out pretty soon.
Very good. Keep checking the monitoring screens.
You really have to be patient for this job, right, Paul?
Yes, that's true. But for now, we're not getting anything. We'll keep on integrating the shots. Hey, the images of the zone have just arrived. Not a single afterglow in sight.
We missed it this time.
Nothing, really?
No, nothing at all. We're still integrating, but it seems that all we have is noise.
You know, it can't work every time.
Leia, can you write the standard entry, please? Beppo Sax alert, 3:55 Universal Time. No afterglow observed. Okay, you can send it. Well, all we can do now is go back to the standard observation program.
It'd be so nice if we could get something on my last night.
Well, you just had to ask for it. We've got a new alert. One alert after another. It doesn't happen every day. Leia, can you write that? This time the info comes from Ulysses' satellite.
Maybe this is it.
I'm starting automatic detection.
You should check our disk space too.
It's okay. I did it before you got here. What do you think?
Oh, did you see that? It will certainly bring us luck.
Well, if you think so... All right, the cursor stopped. We're going to get the first pictures. Let's integrate them.
Wow!
Great! That's amazing.
That's right. I'll keep on integrating the data.
This is not bad at all. Frank, what's the magnitude like?
Wait, I'm starting the photometric measurement application, but at first sight, I'd say something like 18 or 19.
Okay, make sure you measure all the coordinates. Frank, get the standard spectra. Can you prepare the processed images display?
Give me 2 seconds.
Here they are. I've got the precise coordinates. Tarantula Nebula in the Large Magellanic Cloud.
Drinks are on you this time, Paul. It's your dear Tarantula. It's in the Hodge 301 area, to be precise.
I think we're very lucky to capture that light, you know. With all the dust in the Tarantula, it's no easy thing. It's like seeing through a hole. What a stroke of luck.
Here we go. I'm starting the display of the processed images.
Tell me, did you get a close look at the pictures? There is something strange here.
Where?
Look at the difference between the photos. That strange thing, almost in the middle and on the right.
So what?
Here, did you see it? Compare the images. This intermittent source that comes and goes. It's on picture number 21, but not on 22. There it is again on 23, but it's not on 24, and it's here again on 25. This is really surprising.
Wait, hold on. It could just come from a defect in the sensor.
No, I don't think so. It's too regular if you take into account the exposure time. Frank, could you display the superimposed photos while I'm trying to measure the repeat time?
What do you think it is?
It is a periodic or semi-periodic phenomenon. That's why it's almost on every other image. It's a really fast cycle. I have 10 seconds. Frank, I've never heard of that kind of things on a detector. Can you get the zoom ready? I really want us to take care of that. And also, there'll be no better time to show Leia what we can do with our toy. Meanwhile, Leia, can you write up the standard entry? Ulysses alert, 4:17 Universal Time, afterglow observed. But don't waste too much time with this. I need your help.
I am sending it.
Frank, can you center the image?
It's coming, it's coming.
Come on, start the zoom. Let's go.
As impressive as always, the Great Magellanic Cloud.
At the pace we're going, we'll still be here 3 years from now. Here we go. Here's our phenomenon, just on the edge of the tarantula.
Yes, I can see it now.
90. That's it. This is as far as we can go, Paul. If we want to go any further, we'll have to switch to the immersive vision mode.
Okay, I'd like to keep that thing in sight. Get the simulator ready.
Wait, I'm not sure it'll work.
That's right, it does have a temper. The other day it calculated the same image 10,000 times. It was a real joke, like in a Chaplin film.
Really?
Let's go, Frank. Lock on to that phenomenon. I'd really like to know what's going on.
Locked on.
This time it's my turn to start the simulator. Ready, Frank? We'll immediately switch to dynamic mode.
Okay.
Go!
That's amazing. It really feels like we're there.
Leia, I don't know if you know the principle. It's really simple. We do the massive photometric and spectroscopic readings of the whole field. Then, with a computer connected to a database, we calculate the distance from the stars, nebulae, and galaxies. All this from the spectroscopic information. After that, an immersive simulator allows us to move around in real time in the reconstituted 3D structure. What's for sure is that we get amazing feelings with this new tool.
Great! We can even see the interstellar dust.
Hey Frank, have you seen that? It's still there. Looks good.
That's it. We're now leaving Magellan.
Look at our friend. He's still there. This is really exceptional. It's far beyond the tarantula. And our friend keeps on vibrating. Look at that! Frank, can you display the redshift measurement from the spectro? We'll find out how far it is.
Right away.
So what's the redshift?
3.9... 6.8... 9.5. Guess what? It's 10.4. This is about 13 billion light years.
Wow! That's a new world record. Leia, you're going to be able to sign your first article for Nature. Good job, kids. We haven't been wasting our time tonight. We'll have to celebrate that. Frank, what do you think? There's no better time to test the simulator's wormhole.
The wormhole? Well, you know we've never used it in cases like this. Judging by how far it is, that thing must be emitting a huge amount of energy. We shouldn't go beyond the equipment's capacities.
I know, but this is so impressive. We've got to try it. Come on, charge it up. Initialize all the modules.
If you want me to.
Paul, what can we do with a wormhole?
You know that, with the space-time curve, you can move from one point of the universe to another through some sorts of tunnels.
So what's the problem? Could there be a big bug?
No, there's no reason there could be one. This being said, I think we're the first ones to use it on observation in the far-flung regions of the universe. Moreover, Frank is right about one thing. That thing flashing in front of us isn't a joke, considering its energy. Just to be on the safe side, Frank, you'll switch to manual when we approach the target.
Okay, the wormhole is ready. It's set on 12 billion light years. Then we'll switch to manual again.
Okay. Ready?
It seems okay.
Let's go! Start the machine. Black hole, and a huge one.
Yes, a supermassive black hole and its accretion disk. That's great. No one has ever seen that, and it happens to us. Can you see those streams of matter? They must be several thousand light years long. Paul, those huge pieces of matter that are being absorbed, that's what's emitting those flashes. They are accelerated to amazing speeds. Frank, have you started the spectros? I don't want to miss anything. I can't believe it. 3 years working on my thesis, and here it is, in front of us.
Hey, calm down. Let's do this properly. Leia, start recording. Frank, give me the intensity records as soon as you get them. What worries me is that we are very much closer than we planned. Frank, have you switched to manual?
Yes, but something really strange is going on with the controls.
Frank, we keep getting closer.
This is not normal. The wormhole didn't work in nominal mode. Paul, I warned you, this thing is terrifying. The data's gone completely crazy. I don't have control over anything anymore. The wormhole reinitialized on its own. I don't have any space-time data anymore, and the worst thing is that all the captors seem to be dead.
What? Don't tell me we can't take any measurements. Are you joking? We're looking at one of the most amazing phenomena of the universe, and you're telling us that the sensors are dead? Look, we could almost touch it.
Yes, that's exactly what I don't like about this. Frank, what's the...
It's not telling me anything. Not that the sensors aren't working, but the data they're giving me doesn't make any sense. Look at the magnetometer. It's going from 0 to its maximum value randomly. And I'm not even talking about the photometers. This thing must be emitting huge gravitational waves. Maybe that's what affected the wormhole.
All this doesn't sound very good. Frank, we have to get away from this monster. We can analyze the data at the lab when everything's over. Sorry, Leia. I have a bad feeling about this.
Sorry, Paul, but I'm not in control of anything anymore. This is impossible. Impossible.
It looks like we're being sucked in. Paul, there's nothing to worry about, is there? We're in some kind of simulator, right?
Yes, in theory, but I've tried to reset the system. Nothing can be done. We're still getting closer. Frank, we really have to find a solution, Frank. It's getting urgent now. Oh my god, this monster is going to swallow us, Frank! Frank! Leia? Frank? Are you here? Can you hear me?
Yes, Paul, I can hear you.
Me too. What happened?
I don't know. We ought to have literally exploded in the black hole. But apparently we haven't lost contact. Better than nothing. Frank, do you still have control over the machine?
Sorry, Paul, we could have expected it, but now it's certain. We have lost control. We're going straight down the monster's throat, and I don't have any solution. Maybe there is one thing. What's happening is completely impossible. I think something happened when we were traveling, but I don't know what. I'm not getting any feedback.
This is fantastic. These circles of matter, energy. No one's ever seen that. Let's hope it's recording.
I really hope this is a kind of collective hallucination. Otherwise, I don't know how we're going to get out of this. What's that thing?
I have no idea. This is really strange. I have no signal, and we keep receiving images.
They look like beams of light.
Can you hear that?
What?
I think I'm hearing music.
It's coming from all directions at the same time.
Talking about time, Frank, have you checked the space-time meter? Maybe it's working.
Of course I've checked, but I don't have anything. No space-time meter, no sensor, nothing.
Wow.
Go where your eyes take you.
Beyond the impossible membranes.
Embedded strings and worlds.
Worlds made up of tangled up strings.
In the infinity of direction, where it bends.
Ballet of time.
Waltz Waltz of the tempos.
Pulse, pulse.
The heart of the world is beating.
Time passes in the abolished space.
From 0 to 0, no more signs.
Origins eaten up.
There's always something beyond what's beyond.
Move on, move on.
The world of worlds.
Is revealing its secrets.
And your insatiable gaze.
Is never satisfied.
Go where your eyes take you.
Can you hear those voices?
Impossible memories. They sound like ours.
Who knows? Maybe we're traveling through our own subconscious.
Yes, well, at this point. Ballet of time.
Waltz of the tempos.
Pulse, pulse.
The heart. Did you see that? Leah, can you search your database? We'll have to find a rational explanation for all this.
I'll try, but you do realize that it'll be more than hypothetical.
Yes, and as far as the readings go, we're not getting anywhere.
I might have an idea. What if these phenomena, like that one just now, what if there were universes appearing and disappearing on the midst of the strings? Like in Smollin's theory, a black hole could give birth to different kinds of baby universes that would never stop creating themselves, endlessly.
Maybe the simulator is sending us all the images that are in our brains.
This idea of multiverses is something we should check on the recorders when we get back.
Yes, but before we can come back, we need to find out whether we've left. For now, we're really in the dark. Right, Frank?
Absolutely. All my instruments are out of order. I've given up trying anything.
Did you see that one? Its colors.
Yes. The shapes are strange, too.
I'd take one home if I could. A little universe to put on the fireplace. That would look great. What's this? Oh, nothing. Just a little something I brought back from a black hole.
Frank, instead of talking nonsense, what about the sensors? Still nothing? It's getting a bit long. However, what seems endless to us might not be more than 1/1000th of a second.
You're quite impatient. I'm starting to get used to this strange atmosphere. Just watching, quietly, without analyzing anything. It's something new to us.
Look at this one. If we had wanted to invent it, we would have lacked the imagination.
Okay, Frank, no more kidding. We've got to pull ourselves together. We're not going to let ourselves drift forever. Try reconnecting the sensors again. If we can communicate with each other, it means we've kept our own space-time continuum. What does the simulator say? We should be able to work with its real-time clock. At least that would allow us to locate ourselves in our own time.
I'll try, but I can't promise it'll work. I have no control over what's going on. It's like the simulator has a mind of its own.
Leia, I was thinking about what you told us about Smolin. If what he says is right, it wouldn't be impossible for the black hole that swallowed us to contain our own universe.
Absolutely.
You know what? It looks like the simulator is synchronizing again.
I can't believe it. Can you feel that? I feel like I'm getting my senses back. Frank, did you do anything?
Nothing. It's as if we were reconnecting to our space-time.
That would be our continuum, our own dimension.
resonance. There's no doubt about it now. This world is ours. We're watching the Big Bang.
Oh, Frank! There's red everywhere. And this vibration.
This is unbelievable. It's nothing like what we imagined. The Big Bang is not a point. It's something that's endlessly beginning. What we're watching here is incredible. Leia, these look like the first moments of the universe, just after Planck Wall, when the primary soup was completely opaque.
Those sparks. It's as if all the light that's emitted is being reabsorbed by the matter.
And now, it looks like it's getting colder. Maybe the first nuclei are starting to form.
We're coming out of the fog. We seem to be going along the first stages of the universe. It's probably the surface of the last scattering. The universe should be about 300,000 years old.
I've just managed to get a fossil radiation measurement. It's still 3,000 Kelvin, but it's decreasing fast.
The lower the temperature of fossil radiation, the closer we'll be to our time, at 3 kelvins. We might be able to keep track of our movements through time.
But Paul, that would mean we're going faster than time.
Yes, I know, it's completely impossible, but yet I have the feeling that's what's going on. We're completely at the mercy of this stupid machine.
Well, now we can't really see anything. What if it was the Dark Age? The matter is coming together, getting more and more structured. But we wouldn't be able to see anything because the stars wouldn't have formed yet.
You're right, we've got to make sense of it all. I've got the feeling that those are masses of gas being attracted by the gravitational forces of the large structures. Did you see all those strands?
Yes, and when they cross over each other, the point where they meet attracts the masses of gas. They're certainly the first galaxies. That's crazy. And there, the light. Did you see that, Frank?
Yes, you can clearly see the clusters forming.
That's incredible. They certainly are the first star clusters, the primordial galaxies.
Paul, about the fossil radiation readings, the temperature is really decreasing. We're down to 30 Kelvin now.
That's right. The universe is still young. No older than 1 billion years old. We shouldn't lose hope. All this is happening really fast. What's going on? It looks like we're on a completely different scale now.
We must be near redshift 9.
I've got the feeling that the simulator is completely out of control. I don't like that.
Now we can see inside a galaxy. The gas is probably spinning incredibly fast. There's a spiral structure appearing in the center.
Yes, the arms of the spiral are dividing into 2 halves.
And some sort of a bar is forming in the middle.
The gas crossing the bar undergoes huge shocks. It's falling towards the center of the galaxy. That's perhaps what's feeding the active core. Perhaps a black hole.
So now, these are definitely the huge structures of the universe. It's like we've made a huge jump through time. Everything's mixed up. What do you think, Frank?
The redshift is giving us a Z that's close to 0. The temperature is close to 3 Kelvin. I can say that we're almost back in our time.
The 2 wings of an angel. We're witnessing 2 spiral galaxies colliding.
Spellbinding, isn't it? But well, it's not the moment to dream.
Is it gas or stars?
Probably a mixture of both. Flows of matter being torn apart by gravity when they meet.
What's strange is that in reality, all this stretches in time. That's impressive. It's really like we're traveling through dark matter.
Is it real, or are our minds playing tricks on us?
Look at these round shapes. What could they be?
Yes, it's really strange. It's as if our eyes have become sensitive to new phenomena. It seems to me that we are visualizing density thresholds. Well, at least it's the only thing I can think of.
All that we can see shining out there, are those all galaxies?
Yes, they could be the densest areas, the areas where the matter that emits light comes together. Our own matter, to put it differently. It certainly is beautiful, but also a bit worrying.
A collision of galaxies?
No, I've got the feeling that we've changed scale again. I think it's more something like masses of gas collapsing under their own weight. Those white spots are stars being formed. Look at these young stars. They are really close to each other, and when they meet, it generates chaotic movements.
We're going to bring back some incredible data.
Here it is. Fossil radiation is at 2.7 Kelvin, the temperature we detect from Earth.
That's good news. There's a good possibility we'll get out of this that way. Hey, look at this galaxy.
From what my captors tell me, it's 70 million light years away.
We're almost home.
Look, the sombrero. I can recognize it from its cross-section.
We're back in our time now. We're moving through space.
You must be right. But how fast are we going? M51!
35 million light years.
We're getting closer and closer.
Look at what's coming up.
Andromeda, the closest from home.
2.7 million light years.
And I'm telling you, the Milky Way is next. So, Frank, are you in control of the situation?
While the data matches the situation, we're getting closer and closer to the references we have back on Earth.
Good, stay in control. These readings are vital for us.
There it is, the Milky Way.
Do you realize that it's the first time it's being observed from the outside? This is completely incredible.
Now we're going inside.
Unbelievable.
Frank, is it recording?
I told you I'm doing what I can. Do you want me to climb in the sensor myself?
That star, with its planets, what if it was our sun?
And there, this little blue planet next to the sun. Isn't it the Earth?
It sure looks like it. I think we're coming to an end.
The Atacama!
But Paul, there's still a problem. How are we going to get out of all of this?
I know nothing more than you do. What's going on? What's going on? Leia? Frank? I'm completely stunned. You too?
Yeah, I'm a little groggy.
What a strange feeling.
Paul, I told you, we were at the limit of the simulator's power. We didn't know where this could take us.
It's coming back to me now. We had just discovered that strange vibrating phenomenon, and I think that by trying to follow it, we went on an incredible journey. Frank, can you display the processed pictures of the afterglow? I'd like to see them.
Do you see that? There's nothing left. I can't believe it. That luminous dot we saw in the pictures, completely vanished. The recordings! I can check the recordings.
Yes, hurry, hurry.
I'm starting them. What? There's nothing. It's like we've lost everything.
What do you mean, nothing? Check again, it's impossible.
There's nothing more I can do. I'll run the process one more time.
That's crazy. You kept saying you were recording. But what does all that mean? The Great Magellanic Cloud? The Black Hole? The Big Bang? The Planck Wall?
So, Frank, there's really no trace.
I'll try one more time, but really nothing's coming out.
So we haven't recorded anything. Damn it! Oh no, I can't believe it.
I've checked everything. There's nothing I can do. There's nothing. I don't know what happened.
So, did we imagine all that? All three of us? From the start? Oh no, it's not possible. It's just not possible. That night, on the Atacama, my two companions and I weren't about to forget. We'd had access to amazing secrets about the origins of the universe, but we had no real proof of that experience to share with the scientific community. Was it just a dream? I don't know. In any case, the only traces were in our memories. For a long time, we kept these fantastic images deep inside us, as if they were treasures. It was difficult for us to talk about it, as people would have thought we'd lost our minds. I've done a lot of thinking since that special night, and I've had this urge to talk about it. It's true that we've learnt many things during that amazing experience. As we became intimate with space and time, we had a glimpse of the way our universe might function. But the most important thing for me, the thing I'm sure I'll never forget, is the wisdom it taught me. The music of the world is beautiful, but delicate. You have to listen very carefully if you want to hear it, and open your heart if you want to feel its inspiration.
नीट मार्काचो सांबाळ माय पायचे मोल कावल्या मामा रेका दिला बायेन केल्या ताता बाईच्या पाय फोटू